right, I'm actually just going to show you one main word problem to try to keep things short since that last video was a little longer. For your example, just FYI before we get started, the example that I have for you to try on the next one, you would plug in 575 for P, and then plug in for X. So neither one of those should be that difficult, but I do like the Newton law of cooling. So I'm going to use that formula from the beginning that we talked about with the coffee. All right, so I just got that formula from the top. What do I know if it says a batch of brownies are taken out of the oven at 375 of a 375 degree oven and cools to 150 degrees after 20 minutes in a room at 70 degrees. We want to use Newton's law of cooling to determine how long it will take the brownies to cool at 90 degrees. Okay, so we have to know what K is. We know other things to plug in. So we know that initially, sorry, I was trying to make it where my wrist does not make it move all the time. All right, T sub 0, so that's the initial, is 375 degrees. All right. T sub M is the room temperature. So what's the room temperature? Well, that's 70 degrees. And then after all that is said and done, so after some amount of time, what is the temperature? That's called T sub T, like that's what you're finding in your answer typically. Well, we are given the information that that's 150 degrees. And then little t for time. Little t is almost always time in word problems. Okay, so that's the 20 minutes. All right, so let's plug in what we know. So 150 equals 70 plus 70, 375 minus 70 times e to the negative k times 20. Okay, if you write negative 20k, that works as well. All right, so what would we do first? Well, I'm going to get rid of that 70 by subtracting it from 150. I'm also going to go ahead and say 375 minus 70 is 305. Remember, I'm working PEMDAS backwards, so just like the last video, when it comes to solving, and typically with word problems, the hardest part of a word problem is actually setting it up. It's typically not the solving, because if you are ready for a word problem, you are already okay with the solving part. All right, so then I'm going to divide. And I would encourage you that if something when you're dividing is not going to be a pretty number, so in this case 80 over 305, I would always leave it like that or as the reduced fraction. I would not give some rounded, what am I doing? I'm just looking at something. I would not give a rounded decimal. So I'm feeling a little lazy, so I'm not even going to reduce it. I'm just going to keep it like this, okay? And then the 305s cancel. And I am left with e to the negative 20k on that side. So we did not do an example of this in the equations, and I probably should have. So I'm really glad that it's coming up now. Remember that I have an exponential. So maybe it helps you if you put the exponent on the left, just because every time I've showed you an example, my exponent's always on the left. And so I want to do, remember you do log base, whatever your base is, of the answer equals the exponent, right? Well, remember, I don't write log base E. Okay, instead I write ln because that is log base E of 80 over 305 equals negative 20K. So my last step, what I want to type in my calculator to get K by itself, I am going to type this for the most exact, accurate answer. And I challenge you to type it in your calculator to make sure that you can get that K is approximately 0.066914. Now, have I answered the question? I want to know how long it will take the brownies to cool to 90 degrees. No, all I have done so far is found K. So now I have to do the equation again, but this time I know a little more. I know that it's going to be 90 at the end. I know that my room temperature has not changed. I know that the initial temperature of the brownies did not change. The difference now is I know that K is 0.066914. And then T. I'm solving for T this time. Like, I don't know what the time is and I want to. Notice I did put a negative there because the formula calls for negative KT. Okay. All right. I subtract 70 to get 20. I still have 305 here. I still am going to divide, so notice a lot of these steps are the same. Uh-oh, I'm still on eraser here. All right, and I have e raised to some power with t. So to do the inverse of that, I do ln of 20 over 305 equals negative 0.069. Oops, there's another 6 there. I did it again. 14t. The last step would be to divide by that negative. So I'm going to put this entire thing in the calculator. I'm not going to try to do little pieces of it. There's no need. Just put the entire thing to get what T is. And so T is approximately 40.7176. So what does that mean? All right, I solved for T. Cool. What does that mean? It means, so if you want a summary sentence here, it's going to take about 41 minutes for brownies to cool to 90 degrees. And so 70 degrees is, you know, a somewhat typical room temp. Some people like it chillier. I understand that. But so you could think about brownies fresh out of the oven. They're really hot at first to the extent you can't hardly touch them. Then after about 41 minutes, they're still 90 degrees. So they're going to be a little cooler than your body temp, but they're not going to be as cool as the room. Also think about the fact that it's going to bottom out. Like, you're not going to get 30 degree brownies in a 70 degree room, right? So that does take into consideration, and that's why you have to know what is the room temp, because that's going to affect how fast it cools. So if you put it in a refrigerator or freezer, it's going to cool faster. It could also get colder than if it was a 70-degree room. So mix in a little science with math today. You try the modeling problem and your target.